CO News Weekly Recap, March 8th through 15th, 2020. We're going to take a look at some carbon monoxide news stories from this last week, March 8th through 15th. The stories referencing here, though, we're going to talk about combustion air. It's important that we understand how carbon monoxide is produced. So we take a look at everyday combustion. A simple match in fire and in combustion, whether it be in automobiles, petrol or gasoline, whether it be natural gas or propane in a furnace or water heater. Carbon monoxide, all fuels burn to carbon monoxide first. And then if the temperature and the oxygen content mixing with the fuel is just right, we can produce very little carbon monoxide. But if we could visualize carbon monoxide as the red on this, around this flame, you can see that as we produce gas from this solid, that it is burning to carbon monoxide first. It gets into that yellow, and we're burning off carbon monoxide. We're burning off the gas we're producing, but the temperature around the flame cools it again, and we're back to carbon monoxide. Carbon monoxide needs air. It needs oxygen. These following news stories are going to demonstrate that. And as we get to these news stories, we'll take another quick, simple look at combustion. Here's a candle, a semi-solid. It has plenty of air. Okay, now we have an ignition source. We're going to light it. Well, and as we light this candle, we have a very well-developed flame. We can, however, see a little yellow band around the whole rim of that flame. Remember, we're producing a gas through heat. In this case, we're generating gas from wax. As we light it off the wick, we see that there's a space. You can visualize gas is there that we're producing, and now it's reaching that flame. And as that flame, at the bottom of the flame, there's a very well-developed yellow cone. Now, you can't quite see it in this video, but you can see there's a yellow cone. And that means our gas is going to carbon monoxide, and it first enters this flame. As it gets hotter, we're generating less carbon monoxide, but that doesn't get a chance to complete its journey because the yellow band around it, the temperature is impacting the flame, and we're going back to carbon monoxide. Now we're going to do our experiment by placing this jar not completely over the candle, and smothering the flame. We are going to just place it over the top of it, and our combustion gases will fill that jar. And as we notice that our flame starts to shrink or weaken, well, that's because it's not drawing oxygen in like it was. The flame is not able to complete a clean a journey as it was. Combustion gases are tumbling back down and starting to interrupt the oxygen draw to that flame. As a result, if we could get a test probe attached to our carbon monoxide test instrument up inside that jar now, we would see that there would be elevating levels of carbon monoxide being produced. So as we reduce oxygen for our flame, more carbon monoxide is being produced. We need to be aware of combustion air. And combustion air, that's in a lot of places that we encounter. And then the final experiment is that we take that jar and just place it over the flame. And in the process, you can see a bunch of smoke start to be produced, heavy carbon monoxide production, and eventually oxygen reduces the flame to nothing. Now, if people were inside that jar, even though it's a little candle, carbon monoxide has enough potential to hurt or kill you. Well, it's obvious people don't live in jars, or do they? sometimes we tighten up our homes to save energy, and we tighten them up too tight, not realizing that some of our appliances need air for combustion. Sometimes we may do a trip, camping trip, and we may find that by burning things inside our tent that we could use up oxygen. Now, these are all real events. Let's take a look at some news stories. So in this first news story, they found 2 people dead, suspected of carbon monoxide poisoning. When the deputies arrived, they found a heater inside, and it was powered by a propane tank. Again, they were in a small space. They had an unvented heating unit, and their fuel, just like our candle, they were breathing in oxygen, and the fire in the heater was breathing in oxygen. And in this situation, here's 2 Dutch mountain climbers found dead on an expedition. They were camping. They slept in their dome tents. Again, think of this carbon monoxide in a jar scenario. It's believed that a gas stove used for a purpose of preparing meals, it leaked carbon monoxide into the tent. Heck, carbon monoxide was produced while they were in the tent. Again, they were experienced mountain climbers. And again, to all who will listen, here's some people that had some near-death experiences in a motel room. Both of them woke up with headaches. They were there for a tryout, and for skating. And gosh, they went back to their hotel. They woke in the middle of the night with headaches. They took more over-the-counter medication. They returned to the hotel room after, again, another tryout. And they weren't feeling well. They were screaming, had headaches, felt dizzy, and started to vomit. Think about where you are when you travel. Who's responsible for the air you breathe? And again, here's where carbon monoxide prevents a tragedy. Carbon monoxide was coming from a furnace. It was taken out of service, but it was a 10-year-old detector. It was buried under stuff on a kitchen table. That was the difference between life and death. She called 911, and the alarm went off. And in Tipperary, a working carbon monoxide alarm proved vital for a family. They found very high carbon monoxide levels. The family, including 3 children, were evacuated while the brigade carried out the investigation. And here's an image in my mind. An early morning fire at a duplex. One person hospitalized. Well, the image in my mind is, smoke detection, carbon monoxide detection. The other image I'm thinking about here, the questions that I have, is an escape plan. When the firefighters arrived, there was people hanging from second-floor windows. There's an image. Think about it. What's your escape plan if a fire was in your house? Where would you go? What if it was on the other end of the house and the fire separated you from your family? What would you do? Well, remember, carbon monoxide is a poisonous gas. Higher CO level conditions, they include stomach distresses, fainting, heart attack, passing out and in, unconsciousness, irreversible brain damage, and death. Carbon monoxide is a poisonous gas. Let's have a safe week. CO News Weekly Recap, March 8th through 15th, 2020.